On September 20th, the Antarctic ozone hole reached an extent of 24.8 million square kilometers. 2020 was the 12th largest hole on record. In 2019, the peak extent was the second smallest hole on record. But this stark contrast doesn't mean the hole is worsening. That's where weather patterns come in. Colder temperatures are one of the factors that activate ozone depletion, which means that weather patterns play a vital role in determining the ozone hole's extent each year. The Antarctic ozone hole peaks during the southern hemisphere's late winter, when temperatures are at a low and the sun's rays return. The 2020 ozone hole was exceptionally large due to a stable and cold Antarctic vortex, the stratospheric low-pressure system that flows clockwise in the atmosphere above Antarctica. It's there that the colder conditions help support formation of polar stratospheric clouds, whose cloud particles activate ozone layer-destroying forms of chlorine and bromine compounds. These compounds stem from years of human production and used to be found in things like aerosol sprays and refrigerants. Unfortunately, it took years to realize how damaging they are to the ozone. If chemically active forms of chlorine and bromine are present, and there are both cold enough temperatures and sun rays, a reaction occurs on the surfaces of cloud particles that form in cold stratospheric layers, leading ultimately to runaway reactions that destroy ozone molecules. The Antarctic ozone hole was first discovered by researchers at the British Antarctic Survey in 1985. Just a few years later, in 1987, the international community signed the Montreal Protocol on substances that deplete the ozone layer. Countries as small as the Vatican and as far as North Korea signed the deal, regulating the consumption and production of ozone-depleting compounds. Since 2000, human-made ozone-depleting substances have slowly declined, but remain high enough to produce significant ozone loss. These compounds have lifetimes of more than 50 years, which is why we're still seeing their effects on the environment today. The ozone hole over Antarctica is expected to gradually become less severe as chlorofluorocarbons continue to decline. And because of scientifically supported international action, scientists expect the Antarctic ozone to recover back to 1980 levels around the year 2070.